Hello students, now come to the chapter of hydrostatics. We will not deal with any movement in the fluid, we just will look at fluids that don't move, that don't have flow behavior, that are just static. For example, what is hydrostatics? For example, if you have this glass of water here, yeah, and you can find it here on the slides, yeah. If we have this glass of water and we place it on a scale and we want to decide how heavy this is, yeah. Normally you just take the volume of the glass and then you put it on a scales, and then you can say, oh, it's about 200 grams or 400 grams, depending on how much volume is inside the glass. But maybe you can do this experiment at home. Try it, fill a defined amount of water into the glass, place it on a scale and measure the weight. You will get the weight you have calculated for this volume. But now start your first experiment. Put a finger or any object into the water and then look at the scale. What happens? I tell you, it will be more heavy. You will measure more weight if you put your finger into this glass. And this is a bit strange, it's unusual. If I ask you and if what happens, I think 100% of you will tell me the weight will not change, but it will. And why? I can explain it. It happens because if you put the finger inside the water, you will get a higher level of water, and this will cause a higher force onto the scale. So maybe do this experiment at home. Try to do it with a glass of water on the scales. Okay, so let's come to the topic of hydrostatics. I try to explain it a bit in another way. Come to the region of Saarbrücken. Yeah? You know, Saarbrücken is a nice town. We have a lot of historical buildings. I showed you already some buildings where from mining systems, and we have also this water towers, yeah, in this region. There's a really old water tower, a bit newer, a really modern water tower. And what do we do with these water towers? They were used in former times, or sometimes even today, to pump water inside as a tank and use the hydrostatics for your water pipe system. That's how it works. You have here your water tower, and I have a pumping system, and I pump up the water into the water tower, and then it has rest, but we get a hydrostatic pressure, and the hydrostatic pressure depends on the density of the water, the gravity, and the height of the tower, and then we can use the water in the houses. And it's important that our water tower is always on a higher level than compared to the houses. Otherwise the water will not flow to the houses. But this is a bit old technique. Nowadays, in many water systems, we will not use water towers. We will just use pump systems that will hold the pressure for our houses. Okay, but in former times it was much easier to pump it up a tower and use the hydrostatic pressure of the water to get it into the houses. So let's look at hydrostatic pressure and at tanks and pressure inside vessel. Yeah, here's a picture of a vessel. We have water inside or other fluid inside, and we have an object here in this vessel. This element. The element has an area, and now the pressure acts on the area of this element, and this will cause a pressure gradient inside the element and will cause forces on the walls of this body here. So if we know the pressure, if we know the area of this body, we can calculate the force, and then we can And maybe one thing I also want to explain: the pressure in a water tank or in a fluid tank changes with the height. That's an important fact, and we'll come to this later. It depends on the height. At the bottom I have the highest pressure, and at the top I have a lower pressure. So here's an easy example. I have a tank, I have two liquids inside, and it's again the same. The pressure changes with the height. So we have the pressure in the ground is a pressure in the gas on the top of the liquid. Then we have the density rho of the first liquid times the gravity constant times the height inside this first liquid, and then we must add the pressure in the second liquid with the second height. So maybe if you remember, if you imagine your meal, you have oil. Oil is not so heavy as water, and we have water. Both liquids don't mix, and then we have a lower pressure in the oil because the density is only about 840 kilograms per cubic meter, and inside the water we have a higher pressure. Okay. So